Hi guys, welcome back to my channel. In this video, we are going to cover asymmetrical astable multivibrator. We have already covered the basic astable multivibrator, that is symmetrical one. We have already seen the working in detail, how this waveform is getting generated, then important equations. We have already seen that in very detail. Okay, now this video is the extension of the same topic. So I recommend you watching those videos first. You should be clear with the working and basics of astable multivibrator to understand this asymmetrical one. So let's start. From this diagram, it is very self-explanatory that what is symmetrical and what is asymmetrical. Symmetrical square wave is where your duty cycle is 50%, means your T on time is equal to your T off time. Okay. In asymmetrical type, your duty cycle will be other than 50%, 60%, 40%, anything, but not 50%. Okay. So how a stable multivibrator will be able to generate these kinds of waveforms? So this is the circuit diagram of asymmetrical astable multivibrator. The difference you are seeing here is this part. Okay, so in the basic astable multivibrator, in the feedback loop was just one resistor. That's it. Okay, and it was called R. Now that feedback loop is replaced by two resistors and two diodes connected in parallel. Okay, so this blue one is your output voltage, which is bouncing between plus Vsat and minus Vsat, and this red is your capacitor voltage, which is bouncing between beta Vsat and minus beta Vsat. Okay, now pay attention. Now we are going to analyze this much part. Okay, T on period when your output is high. In this part, your output voltage is greater than capacitor voltage. Okay, let's say your beta Vsat is 3 volt. It started charging from minus beta Vsat level and maximum it could reach up to beta Vsat. So let's say it is 3 volt and your output is plus Vsat. Okay, so let's say output is 5 volt. Okay, so what will happen? This diode D1 will get forward biased. Okay, this 5 volt will appear across P terminal and this 3 volt will appear across N terminal. Okay, so it will be forward biased, so it will act as short circuit. And at the same time, diode D2 will be reverse biased because at N terminal it is getting higher voltage. Okay, and P terminal is at lower potential, so it is reverse biased. So this path is open circuit, this path is short circuit. So capacitor is following this path to charge towards VO. Okay, so your time constant over here is RA plus, if we consider some forward resistance of this diode, we can say RF1 and C. Okay, for symmetrical astable multivibrator, your time constant was simply RC, but now it is RA plus RF1 into C. As RF1 is very small, you can ignore this value and you can directly write T on equal to RAC. Okay, now let's see what happens when capacitor starts discharging. Okay, so we will analyze now T off time period, this part. Okay, now output is negative, so let's say output is minus 5. Okay, and capacitor voltage is at minus beta Vsat, but still capacitor voltage at this point is greater than output voltage. So let's say VO is minus 5 and capacitor voltage is minus 3. Now minus 3 is greater than minus 5, so in this case D2 will get forward biased and this will act as short circuit. Capacitor will follow this path and this path will be open circuit. Okay, it is very simple now. So your T off will be, now it is taking RB plus RF2 into C. Okay, so RA is associated with the charging time, that is T on, and RB is associated with discharging time, that is T off. Okay, working is very clear now. We will see some more equations. We will analyze it through equations now. So for symmetrical astable multivibrator, we had derived this equation, and when you assume this R2 is equal to 1.16 times this R1, this whole part, this whole log part gets simplified, it becomes equal to 1, and your T on and T off simply becomes RC. Okay, so we have derived it. T on and T off for symmetrical multivibrator was RC. Now your feedback loop is replaced. There are two resistors, RA and RB. So for asymmetrical, your T on is this and T off is this. Now you are ignoring RF1 and RF2. So your T on will become RAC and T off will become RBC. Simple. So for asymmetrical design, you will need these two equations. So note down these equations, take a screenshot. Now let's understand how duty cycle will be decided. Now for example, RA is 2 kilo ohms and RB is 1 kilo ohms. Okay, and C is 1 microfarad. So what will be your T on? RAC means 2K into 1 microfarad. So you can say 2 millisecond. Okay, and what will be your T off? T off is RB into C. So here it will be 1 millisecond. Okay, so when your RA is greater than RB, your T on is going to be greater than T off. Duty cycle is nothing but T on upon T on plus T off, which is nothing but T. So here T on is 2 millisecond and T on plus T off means 2 upon 3, which will become 75%. So for this example, your duty cycle will be 75%. Okay, so let's quickly draw it. Okay, so here we can see T on is 2 millisecond and T off is 1 millisecond. Now if we exchange these values, now if your RA is 1 kilo ohms and your RB is 2 kilo ohms, so T on and T off will be also exchanged. Your T on will become now 1 millisecond and T off will become 2 milliseconds. So now RB is greater than RA, so T off is greater than T on. So in this case, what will be your duty cycle? 1 upon 3, that is 25%. So let's quickly draw 25% duty cycle. So what did we learn through this analysis? Duty cycle of your output waveform totally depends on values of RA and RB. Okay, so if RA is greater than RB, your duty cycle will be greater than 50%. Because in that case, T on will be greater than T off. And if your RB is greater than RA, then your duty cycle will be less than 50%. Okay, this is simple takeaway from this example. Now let's see some important equations quickly. What is frequency over here? What is frequency of asymmetrical astable multivibrator? Simple, it is just inverse of T. So T on is RAC and T off is RBC. So C is common, so it is taken outside the bracket. So your frequency becomes 1 upon RA plus RB into C. Okay, this is important equation. Then what is your duty cycle? Duty cycle is T on upon T. T on is RAC and T is nothing but RA plus RB into C. So this C will get cancelled and your duty cycle will be RA upon RA plus RB into 100. So these are two important equations for asymmetrical astable multivibrator. So I hope you are clear with the working and concepts and these equations, everything. So that's all for this video. In upcoming video, I will solve the design question for asymmetrical astable multivibrator. I have already uploaded the video where I have solved for symmetrical one, that is 50% duty cycle. You can check it out. So that's all for this video. I'll come back with the design video. If you have liked this video, press the like button, share this whole playlist with your friends and subscribe to my channel. Thank you.